Thanks, everyone. My name is Sid. I'm the chief scientist at Conversica, where we are building conversational AI for business. Uh, Today, we're going to talk about some of the basics and design considerations for building conversational AI and what we learned as we moved to processing millions of conversations from thousands of customers. This is my personal take on the history of conversational AI as compared to the whole information technology. I personally view it as the final phase of the information revolution. We first started with Usenet and similar things, which are really local collection of documents that are available everywhere in the internet of those days. And then people realized that there's so many documents and you need to categorize them better. And so came products like Yahoo directories. So you can click a category and then see all the websites as opposed to it being cluttered all over the place. And then came simple information retrieval when people realized it's very difficult to give a tag for everything. There aren't just these 9 tags that you can put the entire body of information into. And then came, I don't care about tags. I'll just search some keywords and I'll get the relevant documents. And then came things like Google, which not just give you the information as in just the links of the documents, but they also do information extraction, which is they extract summaries such as what are the paragraphs in those documents that answer your query, and if there are certain entities like names and persons that are relevant to the query, what are their Wikipedia pages, and if it's a hotel, where is that hotel, what are its reviews. So that's more advanced information retrieval and information extraction. So all these brought us to where we are today, which is conversational AI. Unique thing about conversational AI is it expects you to, the expectation is that the AI is so advanced that we not only get the documents that are relevant instantaneously, but also get the gist of the knowledge in those documents instantaneously, and not just do it for one query, but have a multi-turn conversation until the user is satisfied. So at Conversica, we are doing our experiments for business conversational AI, and these are some of the verticals we focused on. We started with automotive sales, and we expanded to education, finance, mortgage, insurance, real estate, and technology. So the main application we started with is the alignment problem between marketing and sales. What we observed is that almost like 10% of revenue is spent on marketing by different companies, and 39% of the leads they acquire through marketing go unengaged. So we created a human assistant that can read, write, and understand emails and text messages. But unlike real humans, she is infinitely scalable, or he can work 24/7, and there isn't like a prejudging. There isn't like a filtering. It works with each and every one of your leads. So this is a snapshot of what we discovered to be things that are needed for providing a good conversational AI platform. To begin with, we are integrated with more than 30 CRMs. So when an event happens, as discovered in one of the CRMs, such as downloading a white paper, our natural language generation system dynamically generates a message, in this case over email, saying, asking a lead, hey, thanks for downloading a paper. Do you want to do this or that as defined by the client? And when the lead responds, in this case in English language, the response goes to the natural language understanding engine. And the natural language understanding engine primarily does intent classification and entity extraction. Some of the algorithms we use for intent classification are support vector machines, random forests, and CNN, because intents are really like instance classification problem. You have a response, and you say whether it is this intent or that intent. Or it could be like one of the multiple intents. So that's intent classification. And then we do entity extraction as one of the main other steps. So we use algorithms like conditional random fields and bidirectional LSTM. What they are good is sequential tagging. So there is this lengthy response, natural language response. What are the entities that are present in the response? That's what is done in this natural language understanding engine. And in addition to these, we use several other algorithms from computational linguistics, machine learning, and deep learning. So once we get the intents and entities, if we know that our AI system got them at a high level of confidence, then we go to the next level of AI tools called the inference engine, which tells us, using similar set of algorithms, what actions need to be taken. So intents and entities is what the lead says, and action is what the client specifies as the action the AI should take, having understood that those are the intents and entities in the response. So once we decide on the action using the AI inference engine, our dynamic messaging system, which generates natural language generation summaries, emails in this case, response in reply to this response. So as you can see, this is not a single-turn conversation. This is a multi-turn conversation. The AI and the lead interact with each other until the lead has no more questions. As you can see, some of the other things we have are, as I was just discussing with the guy from Dialogflow, NLP and machine learning is still not an unsolved, is still an unsolved problem. So if there are things that fall behind the cracks, we use the human training desk to not only improve the AI, but to quickly address the concerns or answer the questions of the lead. So we not only just do emails, we do SMS and text, and we do multiple languages, not just English. So I will just take a step back and quickly go through some of the basic, fundamental building blocks and tools and foundations for building conversational AI. So natural language processing, text mining, computational linguistics are all pretty synonymous to each other. Machine learning and deep learning are statistical approaches to doing natural language processing and text mining. And then you do natural language understanding, which is a more ambitious view of natural language processing. You're saying that you're not just processing the text, but you actually understand everything that needs to be understood in the text. So just to give you a brief overview of each of them, so natural language processing involves different building blocks at a document level, a word level, grammar level, meaning level, and context level. So by using all these algorithms, all the way from sentence splitting, part of speech tagging, full parsing, and then sentence simplification, distributional semantics, coreference resolution, etc., of which I will show examples soon. By using all these algorithms, we try to break the response and understand at a document, word, grammar, meaning, and context level what is present in the response. As you might have realized by now, text mining is a hard problem compared to problems in databases, etc., because text mining is an open world problem. The languages are not finite. I mean, there are tens and thousands of languages, and in each language, you have thousands of words, and each day, each year, more and more words start coming in, and even the existing words change their usage. Google, for example, used to be a proper noun, but these days, for example, people use it as a verb. So for these reasons, text mining is a hard problem, and it's an even harder problem to mine information from knowledge bases. And computational linguistics is really a linguistic perspective to text mining or natural language processing. You have different theories of understanding how the language is formed and then apply them to get what is present in the text. And natural language processing these days has benefited a lot from machine learning. There are three main ways of doing machine learning. There is unsupervised machine learning, which is you don't have any data or any annotations, any annotated data. All you have is this chunk of data that is relevant to your problem, but you don't really know which categories they belong to or what entities are present in those data. Supervised machine learning is you have a limited number of annotated examples. Semi-supervised learning is a mix of both. You have a lot of unsupervised data, and then you also have some supervised data. In addition, these days we are seeing deep learning. The way you can think of deep learning is it's a deep layer network of multiple linear machine learning classifiers. And the hypothesis is that given enough data, you're able to represent any kind of function, any kind of complex function with deep learning. And the accuracy of the predictive models do not hit a plateau like typical machine learning models. As you provide more data and as you design complex layered networks, you can basically capture any function underlying between the input variables and the predictor variable. So as you can see, as I explained, natural language is very complex, and it can't be captured in a simple linear function. So that's one of the reasons why natural language processing and deep learning became very good friends. So just to summarize, we have several techniques within natural language processing, and natural language understanding is really the holy grail of NLP. You do NLP so well that you really understand everything that needs to be understood from the response, so you don't need a human in the loop. So the current trends in NLP are transitioning from rule-based approaches, which used to be very famous until the late 1980s, and which are still somewhat prevalent in terms of lexicon-based entity extraction. And more recently, there is traditional machine learning, which is, I don't really know the theory behind it. I don't really know why this should be this intent or entity, but I'll give you enough examples. And based on those examples, I'll let the system pick out what the intents and entities are. And deep learning is a subfield of machine learning, and it emerged because we now have access to huge amounts of data, and we have access to huge amounts of computing power that allows us to build any complex model that we want to, and that is especially becoming more prominent over the last 4 or 5 years. So the role of NLP in AI goes all the way from turning raw big data to knowledge, all the way from information retrieval methods to retrieve what documents contain the knowledge, and then information extraction methods to extract the relevant entities and the relationships between the entities in those documents. And then it also goes to understanding natural language inputs. So for conversational AI and question answering applications, it's not just about understanding what is there out there, but someone is interacting with you. So you need to understand through information extraction what is being conveyed in that question. And then you generate outputs. It could be a summary. It could be a natural language generation response. So you essentially convert structured information into an unstructured natural language appearing response, so that you can then go back to the next input, and then this loop starts again. So information retrieval, just to give you a summary, is poor man's NLP. You don't really understand everything about everything that's there in the document, but you essentially want to know which documents are relevant to your problem, so you can at least provide the user with those documents so they can go ahead and find that information themselves. If you refer to the historical perspective I provided, Yahoo, which provides sort of a Boolean information retrieval, and then traditional search engines are all doing information retrieval. And there are different ways of doing information retrieval. I gave some papers that I did, but I won't go very deeply. One prominent area of information retrieval is we're trying to understand context not just based on the words themselves, but the word vectors. And there are two ways to build word vectors essentially. You can build word vectors using a second-order relationship, which is paradigmatic. That is, the words like Bush and Obama appear in similar contexts, not necessarily in the same document, but in similar contexts across various documents, so they are similar. So essentially, you're creating a synonym dictionary for yourself without any human involvement. And then you have syntagmatic models, which are more first-order relationships. The word president and Obama appears together. So the issue with first-order relationships is, while it is easier to compute, they're not like direct synonym relationships. They're more useful for information retrieval, but they're not as useful for information extraction, so to say. So I've done several experiments with different ways of constructing good word vectors, and I've shown which vectors work best. But I won't go so deeply now, but I'm happy to discuss after the talk. The other big area within natural language processing, which I said is the core of conversational AI, is information extraction. You don't just say this document is relevant to this query, but you go very deep into the document and extract all the entities and relationships in that document. The main areas within information extraction are named entity recognition or sequence class. We choose a sequence classification algorithms to find which slots represent the entities that you're interested in. And once you have the entities, you normalize them to canonical IDs. And then if there are anaphoras or co-references such as pronouns, you disambiguate them with the actual proper nouns or other named entities. And then once you have these entities, finding the relationship between those entities, and then if those entities are negated versus there is a difference between saying that I want to go to AI Expo or AI Expo sucks and I don't want to go, and then de-identifying, which is a flip side of NER, and then sentence classification is a big area now, especially as we want to, irrespective of what the entities are, we first want to find out what are the intents present in those responses from the users. So sentence classification algorithms is a sub area within information extraction that addresses that. Again, I've presented some examples from the research I did, but we can go over that offline. So we can use conditional random field algorithms. We can use unsupervised algorithms. We can use lexicons for named entity recognition. And then we can do sentence simplification to be able to do information extraction better, because sometimes some users tend to write their responses in convoluted way. So breaking them into individual clauses or even separating the clauses could sometimes help. And then you have co-reference resolution, which resolves the pronouns and the other anaphora in the sentences. And then you have different ways to identify the relationship between different entities based on semantics, based on the lexicons, based on the syntax, and based on the context or pragmatics. So the other area within information extraction is knowledge summarization. As an example, you could build a system today where the query is a particular disease, and then the information retrieval step gets all the medical literature or any kind of literature that mentions this, and the information extraction step gets all the treatments in those documents, and the sentence ranking step or summarization step or the natural language generation step summarizes what information you found. And you can also do research on constructing knowledge bases based on information that is present across. And you could expand that work into mining information, not just from text documents, but also from PDF and even images. And you can also use information from Yahoo Answers or Twitter, etc., to ingest that information or to directly answer in social media. And you could also study who are the main people that are involved in a particular topic, or who are the main organizations that are involved in this topic. So I hope this kind of background provides you a good background on some of the things involved in natural language processing. But going back to Conversica, the 4 kinds of natural language processing we use at Conversica are, we originally started 10 years back where we started with limited data, and so we started with rule-based approaches that work very well for simple entities and simple intents. And as we got more data, we found that traditional machine learning is more maintainable. And today we have thousands of customers and millions of conversations, and a lot of them are annotated by our human training desk. So we use deep learning methods. And we also found success by combining all these methods using ensemble approaches. So at Conversica, we use NLP to turn raw big data to knowledge, to understand what the user is emailing us about, what the lead is saying. And then we use NLP also to respond by email or SMS, not just in English, but also in Spanish, French, and other languages. One of the ways we define this is we have 4 main intelligences. One is a natural language processing code that reads, classifies, and understands the responses. And then there is an inference engine which takes the intents and actions we get from the natural language processing code and gets these are the actions that are present. And the natural language generation code takes all the actions and know what we know about the user and converts them into an email or a text message. And we can't undermine the human intelligence to improve these 3 artificial intelligences as and when they need help. So the main desiderator for conversational AI, as we discovered through our years of experience, is promptness, persistence, personalization, and performance. Promptness this is something that AI could be used very well. One thing that drives people away is if you send an email and you get a response like a week back or a month back or a year back. Artificial intelligence algorithms can understand these things very quickly and are able to respond very quickly compared to human sales reps. So we found that in some cases, prompt AI responses helped us preserve leads. And the other aspects are persistence. As opposed to humans who could get tired after talking to a lead for a couple of times, artificial intelligence system can be both engaging but also be persistent. And more important is personalized. If the AI sounds very botty, you would recognize that it's not worth conversing. And with Conversica, we don't really advertise that it's a bot. But most of our people think that they're actually talking to a human being. The way we are able to personalize so well is because we're able to understand the intents and entities very accurately, more than 95% accurate in most of the cases. That leads us to also decide what actions to be done well. And it also extracts all these entities more accurately related to the person, so we can provide personalized emails. Because of all this personalization and promptness, our AI responses go less to spam than the number of human marketers who send emails to me. That's actually quite an accomplishment for AI. And this is a simple example of our conversation, but the main things are engaging, qualifying, and follow-up. We found that our AI takes the grunt work of the team. It doesn't replace humans, but it increases the impact, and it converts those leads that you don't have time to follow up, and you're able to do other things. And we have a dashboard, too, where you could monitor. Thank you so much for listening to me. I couldn't cover a lot of things in detail. If you want to talk to me after this, we're happy to.